Hello, physics. This is Mr. Janowski. This is Chapter 5, Homework 2, Problem 7. This is the dart problem. So a darts player throws a dart. The dart leaves his hand traveling perfectly horizontally with an initial velocity of 12.4 meters per second. The dart sticks in the board at a height of 0.098 meters below the release point. So let's do Part A. Boop. Step These are H's. How much time does it take for the dart to drop in height by that much? Okay, so in Part A, we're looking for time. So time is question mark seconds. And for Part B, how far away from the board was the dart released? So we're looking for how far did this dart go sideways? So delta x is equal to question mark meters. That's what we're looking for. On to step 0. And let me stress this again. Step 0 is find the components. And if you watched the last video, you might remember that I made a big stink that step 0 is find the components. It is not. That's a colon over here, by the way. I'm going to fix that. That looks terrible. It's all confusing. Step 0 is find the components. Step 0 is not draw a triangle. Sometimes you have to draw a triangle, but you don't always have to draw a triangle. So let's look at this in this situation. How is this dart moving initially at the start of this problem? The dart leaves his hand traveling perfectly horizontally with an initial velocity of 12.4 meters per second. So that means at the start of this problem, V initial is perfectly horizontal. So V initial is 12.4 meters per second. Now we need to find the components of this velocity. So how much of this velocity is horizontal and how much is vertical? Well, all of it is horizontal. Vx initial. This dart is only going sideways. So my V initial is my Vx initial, 12.4 meters per second. And how much of it is vertical? We need that component too. Vy initial is 0 meters per second. At the start of this problem, the dart is not going vertically at all. It is only going sideways. As soon as it leaves the dart player's hand, it's going to start moving downwards. But at the very beginning, it's not going sideways. So we have that. So on to step 1. Step 1 is make a sketch. This sketch is important to get right. This one's a little bit tricky. So let me draw this as well as I can. So dart player throws the dart perfectly horizontally initially. I'm trying to draw the feathers. The little flags on the back of the dart. So throws the dart like this, perfectly horizontally initially. What's the dart going to do? It's going to do something like this. And then it's going to stick in the dartboard. Boop. Although I guess technically we're stopping the problem right before it gets to the dartboard. So it's going to stick in the dartboard. I think I'm doing pretty good at this. This is not easy to draw this well. At a height that is 0.098 meters below the release point. So what does that mean? So let's look at the height we started at. I'll change colors to make this a little easier to see. So this is the height we started at. Okay. What that means is this difference in height right here, this is delta y, and this is 0.098 meters. So that's what's going on there. That's what that means. So on to step 2. So remember in these problems, it's two-dimensional, so we actually have 12 variables that we need to figure out. And I like to draw the y variables first, because I know I'm going to do the y side of the problem first. So y initial, y final, vy initial, vy final. Remember, there's 4 different v's in this problem, so use all the subscripts you need to keep everything straight. There are 2 different a's. So I'm going to call this a sub y and t. And then on the x side, we have x initial, x final, vx initial, vx final. That still looks like a y, vx final, a sub x, and t. All right, so 12 things we've got to figure out. So yeah, let's figure this stuff out. Y initial, always make that one 0. That hasn't changed since last chapter. So that means this height that we're starting at here, that's Y initial. And importantly, remember this height is the same height over here. So this is also Y initial. That, I'm indicating that height there. Y final, it is the height that we end at. So it's this height here. And that is 0.098 meters below Y initial, which was 0. So this should be 0.098 meters. Very confusing stuff. But that's how it is. Yeah, in this one, it's hard to get, step 2 right if you don't have step 1 right. Step 1's a little bit confusing in this one. Vy initial. Okay, your initial velocity, you get that out of your step 0, your components. Vy initial is 0. Remember, this dart is moving perfectly horizontally at the beginning of the problem. Vy final. How fast is the dart moving at the end of the problem? It looks like I forgot to put speed lines in. Well, the dart is definitely moving at the end of the problem. It will be going down and to the right in my picture. So it has some downwards velocity, but I don't know what it is. So question mark, meters per second. A sub y. What will accelerate this dart in the y direction? That will be gravity. And gravity is minus 9.8 meters per second squared. T, how much time does it take for the dart to get from here over to here? We don't know that. That's one of the things we're looking for. So T is question mark seconds, which means over here, the exact same T, also question mark seconds. X initial, where does this dart start off sideways? Always make that one 0 meters. So what that means is like right here. I guess that's the front of the dart. So that's X initial right here. I drew that kind of funny. This line here. Okay, so that's X initial. X final, where does the dart end sideways? That's over here. Okay. We don't know this. This is what we're looking for. I mean, really, we want to know the difference between X final and X initial, delta X, but we don't know it, so that's that. All right, Vx initial. How fast is the dart moving sideways initially? Go back to your step 0. Vx initial is 12.4 meters per second. Because in this problem, the thing initially was only moving sideways. So all of its velocity was X velocity. None of it was Y velocity. Vx final, again, skip it for now. Look at A sub X. So again, on the Y side, gravity accelerates the dart down. On the X side, what accelerates it sideways once it leaves my hand? Nothing. Very common in these problems that A sub X is going to be 0 meters per second squared. Okay, so now back to V sub X final. The dart was initially moving 12.4 meters per second. It did not accelerate sideways because A sub X is 0 meters per second squared. So that means it is always going 12.4 meters per second, which means V sub X final is equal to V sub X initial is equal to 12.4 meters per second. Confusing stuff. I know. Takes practice. Once you get there, once you do enough, it starts to become more natural. So step 3, what are we looking for? Well, first we want time, and we're going to get time on the y side. So I'll put step 3A over here. That's what we're looking for. I won't even circle it. It'll just get messy. Step B, how far from the board was the dart released? Okay. So in part B, I guess it's step B. Part B, that's what we're looking for. So far, so good. Now we need to pick an equation, and we need to start on the y side. Always start on the y side. So step 4A, which is step 4 on the y side. We need an equation that can get us time and doesn't have V final in it, because we don't know V final. So 1 has time, 2 has time, 3 doesn't, 4 has time. So 1, 2, or 4. Which one doesn't have V final? 1 will work. 2 won't, 4 won't. Those have V final. So we're going to be using equation 1. So delta y is equal to Vy initial times t plus 1/2 a sub y t squared. All right, is there a useful 0? There is. Vy initial is 0, which means this term here 0 times t is just going to go away. And that gives me delta y is equal to 1/2 a t squared. So on to step 5. I need to solve this for t. So I'm going to do some of the math really in a condensed way because I'm running out of room and I'd like to get everything on this one board. I think that might be helpful. So if I solve all this for t, what am I going to end up with? I'm going to end up with t is equal to plus or minus the square root of 2 delta y over a sub y. If you don't believe me, do the algebra yourself. You will see that that is correct. So we've got that. You end up with t is equal to plus or minus the square root. Oh, there's not enough room, really. The square root of 2 times delta y is minus 0.098 meters divided by a sub y is minus 9.8 meters per second squared. You do all that, and you will get a time equal to, it's going to be the positive one. I'll skip that because I'm running out of room. 0.1414 seconds. Put a box around it. Come on. Put a box around it. Step, we solve for the right thing. Time in units of seconds. It's, a little bit more than 1/10 of a second. Does that make sense? Is that how long it takes for a dart to leave your hand and get to the board? Yeah, that happens pretty quick. I don't know if you're darts players, but that happens pretty quick. So what that also means is over here on the right side, t is no longer question mark seconds. We just figured out what t was. T is actually 0.1414 seconds. So that's no longer a question mark. We now know what that number is. So which color do I want to go to? I'll stick with black. Okay, so step 4 on the x side, so I'm calling this step 4b. Which equation? Don't even think about it. Always pick equation 1. Delta x is equal to v sub x initial times t plus 1/2 a sub x t squared. That's next, a sub x t squared. Are there useful zeros? Are there any useful zeros? There are. A sub x is 0. So that goes away, which means delta x is equal to v sub x initial times t. Which means, I guess I go to green here. Step 5 on the b side is going to be fairly simple because we have the thing we want on one side already. Delta x is equal to v sub x initial. That's this number here. 12.4 meters per second times t, which is that number we fought so hard to get on the first side. 0.1414 seconds. So we've got that. Ask your calculator, what is 12.4 times 0.01414? And your calculator will tell you that delta x is equal to 1.75 meters. Put a box around it. Do step, we solve for the right thing. We gave it the right units. 1.75 meters. All right, it's about 2 meters, so that's about 6 feet. Is that about how far away you stand when you throw darts? Yeah, that sounds right. So you give it a check. So again, these problems, there's a lot going on. If you're looking at this at the end, it probably looks like this is too much math. I can't do this much stuff. You can do this much stuff. Eventually, you'll be able to do this much stuff. Just take it piece by piece. Keep doing the steps. Keep following the system, and you'll get the hang of it. So hopefully you found that helpful.